Since I don't have anybody to introduce me, I guess I'll just start. Your next speaker is a former alumni of HackReactor Austin, back when it was known as Maker Square, cohort 21. That's about a year and a half ago, and I'm now a senior front-end engineer at Deveris, which is a company here in Austin which makes background checks. Last year I gave a talk called Things I Wish Maker Square Had Taught Me. And this year I'm going to be giving a talk called Black Magic Javascript Tricks and Things I Wish HackReactor Had Taught Me, Part 2. Very informal. Come on in. Have a, don't worry about it. It's all good. So just to start off, the things I'm going to show you now, you probably shouldn't use. This is not necessarily what you'd call good code, but it is interesting code. That is, some of this is really crazy and it's really kind of black magic stuff. So this is a warning. We write code for two audiences. The first audience is the computer. The computer doesn't care what we write so long as it compiles. In fact, the computer doesn't even care if we're right. It will do exactly what you tell it to do, not what you want it to do. You've heard that before. It will also tell it what you do, what you tell it to do. It will also do what you tell it to do extremely fast. But if your code is written in a way that people can't understand it, it's going to take longer to add features. It's going to take longer to debug. It's going to take longer and be more frustrating. Always code as if the next person to maintain your code is Dexter Morgan, and he has your home address. Okay? So this black magic stuff, it can be powerful. It can be clever, but if you're working with developers not used to these ideas, which is 90% of them, just stick with the classics. There's nothing wrong with a for loop. There's nothing wrong with using standard old callbacks. There's nothing wrong with anything that's easy to understand and is just straightforward. So let's start off with a few simple pointers. Some of you got that joke. If you didn't, these are pointers. These are actually just integer values in hex. They're just numbers. And they're typically used in lower level languages like C. You guys probably already know this. Pointers are memory address values. So imagine your computer memory is accessible from a single array. The index of that array is 0 at the start. And then whatever kind of memory you have, 64 gigabytes of memory, 128 gigabytes of memory, that's all accessible through your pointer index. And it's called a pointer rather than an index value because you typically use it to point to a particular memory address. Well, why is that useful? JavaScript doesn't even use pointers. You don't have to worry about pointers. Or does it? Dun, dun, dun. Well, yeah, you don't have to worry about pointers, but it does use them, and in ways that even now you're going to start realizing, hey, this is a pointer happening, even if I don't see it in the code. This is a bit of C code. I don't know how many of you have seen C, but JavaScript shares a lot of language features with C. C is kind of like the Latin to maybe not JavaScript is English, but maybe JavaScript is more like Italian in this metaphor. So, I mean, you can probably understand most of what's going on here. You've got a function here called getNextRandomValue. Well, it just returns a random value. This is C's version of math.random. You have a populate array, which takes 3 parameters and does a for loop on something. That's all it does. And then you have this int main void, which basically initializes the variable, and then it passes it in. What you may not really understand is this crazy little @ sign right here, or this little star right here. Well, what the interesting thing about C is that it predates the modern programming languages, because without C we wouldn't have the modern programming languages. So a lot of things we take for granted, C doesn't have. But it still has all the power that later languages have. And how did they solve this problem? C doesn't have higher order functions. How do you solve How do you get higher order functions in a language that doesn't have them? You can't pass in a function as a parameter. You can only pass in ints, chars, and another few other primitive types like structs. But in C, every function has a memory address. And every memory address can be expressed as an integer. Remember, the memory address is basically like an array with a pointer to that, to where the function starts. You can use the @ symbol to get the function at a particular memory address. To get the memory address of the function. So what is it doing here? Populate array takes an int as its third parameter. This is a function, right? No, it's an int, because it's getting, with this little ampersand, the integer value of the pointer of get next random value. And then when you actually declare it, you actually already are changing it back into a function. You're basically saying, get the function at this integer value. And that's why you see this extra void here, because now it knows what type of function it is. C is a type language, so it has to know. So there you go. Essentially, what you're doing is the same thing as this in JavaScript. You're basically doing the exact same thing the exact same way, and I would not be surprised if behind the scenes the exact same thing is happening when you're passing in that higher order function. What you're really doing is you're passing in the pointer, which immediately gets translated into the function at that pointer. Because JavaScript handles this for you. You don't have to think about it. And it's really, really easy. And it's really, really fun. And that's why a lot of people love JavaScript and why it's become one of the most popular, if not the most popular language today. The computer is never smart enough to know what you really mean. It doesn't know what a function is. It just knows math. It just knows numbers, letters. Everything has to come down to a 1 or a 0. But JavaScript abstracts that information for you when you need it. Which brings me to the next point. When you pass by reference, instead of passing by value, you've heard those terms. What you're really doing is passing a value, but it's the value of a pointer. So that brings me to my next thing. How many of you are familiar with ES6 const? Okay? Well, I'm here to tell you const ain't. Okay? I mean, it will kind of work. When you see the keyword const, that value isn't going to be reassigned. You have var a equals 1, console log a at 1, and then you reassign it to 2, console log a is 2. Let does the same thing. When you try to reassign something declared with const, and you console log it and then reassign it, you're going to get a type error, because you can't reassign a const. You can't reassign a value assigned to const. So what is the value, though, at that variable? So let a foo is assigned to 2, let b bar foo is assigned to the object. Well, here's the thing. If you assign const c equals bar foo, if that's true, c should always equal bar foo, because it's a const. But here's what happens. So let's declare const c equals bar foo. We can see it's correctly defined here. So let's reassign c to bar unfoo. Unfoo is the evil version of foo that we want to avoid mutating to. Hey, we caught it. The const prevented it from being reassigned, and it gave us this big error. But why don't we just reassign c.bar to unfoo, and then log c, uh-oh, evil unfoo strikes again. Why does this happen? You can't change a variable declared with const. But if that variable is really just a pointer pointing to the reference, you can modify the value at that reference. That C is always going to point to that same object. But that same object can change and mutate. If you really need to lock out an object, you can use object.freeze, and it's part of the CS language. Here we go. So bar is unfoo. C bar is, we're going to freeze that now, object.freeze. And when we try to assign C bar to refoo, if we console log C again, it's going to be bar unfoo. Didn't change. It's been frozen out, which is a good thing because refoo is even worse than unfoo. So it prevents reassignment, prevents the addition or deletion of keys, prevents primitive values from being changed, but not values of nested objects. So we have a D here. D is completely unrelated to C, but we still want to lock them down. So we have const D, baz, bang, biz. And I chose these words because they're fun to say. D is baz, bang, dig, they're difficult to say as well. So we freeze it up. Baz, bang, biz. D, baz, bang, biz. D, baz, woo. Woo! D, baz, still bang, biz. Not woo. Bang, biz. When did I turn into Dr. Seuss? Okay. So we can't, so basically we've frozen that. We can't reassign D.baz. But we can reassign D.baz.bang, because even though baz is frozen, what is frozen is a pointer to this object. And that object can be modified. And so we type in d.baz.bang equals inner woo, and then we type in d.baz.bang. It'll return inner woo, and you can see baz is now bang and inner woo. So this is one of the reasons that immutable.js exists. There's a school of thought that you want to avoid mutation whenever possible. I don't subscribe to that school of thought. I subscribe to the thought that whatever is easiest and to understand and easiest to work with. But there are some cases where you want to avoid mutation at all costs. In that case, immutable basically creates a specialized immutable object, which is, as you might guess, immutable. You can do all sorts of things to it, but the core value doesn't change. And this is the reason that they had to invent that, because that was not part of the language. So why am I talking about pointers and references if JavaScript doesn't really use them? I mean, you could have gotten through this course without really understanding what a pointer was or whatever. Well, one of the reasons why is because there's a new technology coming up called WebAssembly. And WebAssembly uses C++, C code. It's not mature yet, but there's going to be a lot of crossover in the next coming years. Not even like the next 2 years, like the next 5, 10 years as the technology matures. And you have to be able to work with pointers and understand more about how to get the best out of your memory, because we're going to be able to access speed optimizations in the hardware support that we currently only could use with desktop apps in the browser. Now, there's been a ton of apps that have been replaced by the web. I remember I used to use Eudora, I used to use Outlook, I used to use instant messaging clients. Now I just use Slack. And come to think of it, I use Slack for all of that. I didn't even realize that until just now. But it's all web apps. But these haven't been replaced yet, and that's high-end graphic programs, Adobe Photoshop, Apple Aperture, high-end audio, high-end video. When I go home to edit this video, hello video audience. When I go home to edit this video, I'm going to do it on Adobe Premiere, which is a desktop app, because the technology isn't there yet. There's some, if you go to YouTube, there's some video editing capability, but it doesn't take advantage of your computer's native hardware. And eventually, the way that I think things are going to be going, we're going to see a lot more people needing to understand the lower level languages. JavaScript is going to be the king of the hill for a while, but it never hurts to understand more about the underlying code, because even if WebAssembly doesn't use C, if it uses some other thing, being able to understand the code better allows you to reason about problems, it allows you to do greater things, it allows you to work even with technology that you're not familiar with. At Deveris, I work with a Cold Fusion backend. I don't know Cold Fusion. It's very similar to JavaScript, I've told, but I've not worked with it. There's some things that it doesn't have that I'm used to in JavaScript. So how can I work with it? Well, I understand the underlying logic. So when I need to look something up, I can look it up pretty simply. So you may end up using WebAssembly, you may not, but understanding pointers, whether or not you use them, makes them a strong tool in your toolbox. Okay, so next, let's talk functions. Currying. How many of you are familiar with currying? A few people. Okay. You've done currying, though you don't know you've done currying. You've all done the underbar, underscore kind of thing a couple times, I imagine, by now. Some of the things you were asked to do, I believe, were currying, although you didn't realize it at the time, especially when you were asked to write a function that returns a function. It's pretty much what currying is. It's also known as partial application because you basically are taking a function that takes a number of parameters and splitting it up into one function that takes some parameters and that returns a function that takes the rest of the parameters, so that you can kind of apply it now and use it later. So here's one way to do it. This is actual code. Well, it's sort of actual code from my job in production. We have a library called SuperAgent that we use that has a request that we've already imported. So don't worry about that. Don't worry about the promises. Just worry about this. This getFromServer function takes an endpoint, takes a token, which we need to use to authenticate to the server. The endpoint tells us where we're going on the server. And then the query parameters tell us what we're looking for. Every time I use this function now, like it is, I have to remember to enter the endpoint. I have to remember to enter the token. I have to remember to enter the query parameters. And I have to remember to do it in that order. So you could remember that every time. Or you could do what I've done here, which is create this curried get. What I've done is I've created a function that takes token as a parameter, just the token. And that's going to return a function that takes the endpoint as a parameter. And then after that, that's going to return a function which takes the query parameters. And that's going to return the result of calling getFromServer endpoint token query parameters. So what I've done here is I've created makeAPI, which is a function that takes a token and it returns an object. And this object has a users method, which is really curried get with the token we provided, and a hard-coded users endpoint. Blogs, curried get token blogs. Pictures, curried get token pictures. So that when we use this in the code, I can now say const API equals make API, pass in the token, and now when I want to use the API, API.users, and I just put in the query parameters, and you can use it immediately. Then data, console log data, same with blogs, same with pictures. And that way, I mean, like, you could just type in API users and type in getFromServer users token query parameters. API blogs, or getFromServer blogs token query parameters. And the fact that I'm having trouble actually reasoning this out in my head is one of the reasons why it's so much simpler just to say, yeah, API.users. That's the user endpoint, and all I have to do is pass in the object. It'll take everything there. I don't have to remember to pass in the token. It'll just be done. And that's the power of partial application. So it helps a lot with things that are same kind of thing, different configuration. This is FizzBuzz, but it's not FizzBuzz. It's a function that generates a custom FizzBuzz. It takes a fizzer and a buzzer, a start and an end. Well, it takes a fizzer and a buzzer, and it returns a start and the end. So if you wanted to create the classic FizzBuzz, you can create FizzBuzz generator 3.5, and then you can call the function that it returned, classic FizzBuzz, with 1 to 20, and you've got your classic FizzBuzz. Or you can get funky with it. You can fizz on 4, buzz on 7. And you can type in funky FizzBuzz here. And if you wanted to, if you don't want to create a new variable for it, you can just skip a set by calling the function and then immediately calling the function it returns. So basically, this happens a lot when you're talking about test versus production database configs. This is just some real-world examples. You curry the login information and all the data you need to connect to your test database in your test code. And in the production code, that gets swapped out with your actual production data. So that way, when you're testing, when you're in development, you're never touching the production database. Which, trust me, you never want to touch the production database. Touching the production database in test is how good people get fired. So don't do that. It's a very useful trick in that case. We've already seen similar API calls. File system operations. You've used, I guess, you've used Node read file and read file sync and all that. And it's a lot of information. If you're doing the same thing over and over again, wouldn't it be great just to have like a very simple function that you can call again and again? Well, just curry it. Because you're always going to, the information isn't going to change. And you'll be able to partially apply it and just be able to reason about the code more easily. It basically can be used anywhere. You might use a class constructor, only a little simpler. As you get more into, you guys really haven't got into the difference between like why you would choose the class-based architecture, the object-oriented architecture versus other architectures. But this is an alternative if you don't want to use object-oriented programming in a scenario that traditionally uses object-oriented programming. This might be a little bit old for you guys. This is Alfred E. Newman, whose famous slogan, "What me worry," has been changed into, "What, me curry?" And so why do you want to curry? It results in shorter, tighter code that gets to the point in the fewest lines possible. There's less repetition. When do you want to curry? When writing out the functions by hand, in each case, has become the kind of boring, repetitive task that computers are really good at and humans hate. So this is a quote modified from Nathaniel Bornstein, one of the greatest programmers of our time. It would be noted that no ethically trained software engineer would ever consent to write a nuke Las Vegas function. Basic professional ethics would instead require the creation of a nuke city function to which Las Vegas can be passed in as a parameter. So here we use curry to create the nuke city. We create arm nuke, takes a target, and returns a function that nukes the target. So we have a red button here, which is just an object. So red button.Las Vegas arms the nuke Las Vegas. Disney World arms a nuke for Disney World. This is actually from some contract code I got from a guy named Sorry. Yeah. So there we go. So how do you do this? Well, we can do this manually like we did, or there's actually a function you can write called curry that just takes anything you want and just curries it. So let's say that you have an add function, and for whatever reason, you're always adding 7, and it's always 7 in most cases. You can create this curry function, which takes. Are you familiar with .spread yet? Yeah. Okay, so you can take the function as your first parameter, and your curried arguments. That is all the arguments that you've already gotten when you create the curry, and return a function that takes new arguments and then apply. You familiar with ffly? It basically takes the function and then calls it with the curried objects concatenated with the new arguments. So basically when you add 7 equals curry add, comma 7, it basically creates a function where a is always going to be 7, so that it's really equivalent to b returns 7 plus b. So add 7.3 returns 10. Oh, one last thing before I begin to move off of this topic. You may hear about some hot programming languages that use functional stuff like Haskell, Elixir, Elm. Some of these languages actually don't have a way to use multiple parameters. They do everything via currying. So this is an example of some Elm code. And I'm not an Elm expert, so I made it as simple as possible. Basically, x, y, z equals x plus y plus z. Partially apply equals add fun 2. Partially applied 1 equals yz, returns t plus y plus 2 plus y plus z. So yeah, I'm not an Elm expert by any means, but Elm, Haskell, a lot of the really cool up-and-coming functional programming languages that people talk about when they want to sound, well, pretty much as smart as they are, but, because there are use cases for them. If you want to, you can Google functionality, if for no other reason than to sound smart. So we're going from functions now, that's curry, to functors. Ooh. Okay, so what is a functor? I could explain this in the academic mathematic way. Actually, no, I can't because I'm not that good. But a functor is basically anything that you can map over. That is, anything you can put into a function, like, for example, an array. Console log 123 map x equals x returns x times x gives you an array 149. And so what else can we map? Well, this is where it gets really funky. And don't try to understand this if you don't get it. Don't worry about it. I'm just trying to expose this to you now. You're never going to use this at HackReactor, probably. But I'm just trying to blow your minds a little bit with some stuff that, even most programmers don't think about this kind of stuff. 99% of programmers couldn't tell you what an identity is. As I said, this is not necessarily the code you want to use in production. I'm just trying to expose you to ideas so that later on, if you see a problem that really calls out for an identity, instead of writing a whole bunch of code, you can use the identity, and people will think you're a genius. And if you want to, take credit for it. Make sure that nobody knows that you didn't come up with it yourself, because they'll never know. So this is the object-oriented version of the identity called a wrapper. So we have our curry function, and we have our class wrapper. Our class is an object that has a constructor that uses the this keyword. How many people in here are using the this keyword already in JavaScript? You haven't got to this yet? This is really something that's hard to wrap your head around, but in this case, it just means that whatever instance of this class you call will have its own value called this.value. So essentially, when we create a new wrapper and we pass in the value 39, that goes into the constructor here like any other function, and we assign it to this.value so that when we console log it, we get an object value 39. So here's our add function. Here's our curry function add 3. So we have something plus 3. What we can do is we can take something we created with the wrapper above and then map add 3 to it, which means in this case, map is something that takes a function and then will return a new wrapper, that is, recursively create a new wrapper which takes in the result of the function applied to this dot value. So if the value here is 39 in something, we've assigned this dot value to 39. Then when we map over something, we're taking a function and we're applying that. We're running that function on 39. We're not passing in a new parameter. We're passing in the function that parameter runs on. And so when we console log something plus 3, we get a value of 42. Okay? This is confusing. It's hard to reason about. In fact, it's even counterproductive, and I don't actually like to use wrappers. But the idea is that you can basically flip the typical function parameter relationship on its head. Instead of passing in a value to a function, you can use wrappers to pass in a function to a value. And this is the more object-oriented and a little bit easier to reason about thing called identity. Identity is fundamentally similar. You have, in this case, identity is a function that takes the value and returns an object that has a property called value that just is the value. It also has a property called map, which takes the function and it returns an identity, a new identity, which passes in as its new value whatever the function applied to that value is. So we have a value here, a function here called square. Square x returns x squared. We're going to create a new identity. ID2 is identity 2. And if we console log it, we get the value is 2, and the map is a function. If we console log id2.value, we're going to get just the number 2. So if we pass in id2, but then map square over it, and then get the value, we're going to get 4. Because when we console log id2.map, before we get the value, what we've returned here is a new identity, which takes 4 as the value. And then to get that value, we just value it. And this is useful because now, if we wanted to get, say, the square of the square of the square of the square, we can take id2.map square, and then map that over square, and then map that over square. Say, does this kind of look like a promise then chain to you guys? When you have promises, and it depends on how they built it. There's many different promise libraries. There's a sequence written by Kyle Simpson. There's Blackbird, and then there's the ES6 standard bog standard promises, which you can polyfill into ES5. But they're all fundamentally using this same pattern here, or this same pattern here, where you're returning a new type of object that is itself. And this is very useful. Here are some more functors that you could see. I'm not going to go into this because these are just examples of functors. We can map over a dictionary. Let's say we have a name game, new mappable dictionary, Adam, Chill, and Chuck. The function we're going to map is let's do B, where we take the string and contact Bo B. So we have Adam, Adam, Bo, Badam, Jill, Jill, Bo, Bill, Chuck, Chuck, Bo, Buck. I'm not going to do F. And that's, don't worry about all this. It's gobbledygook. But the point is you can use this with an object. You can map over an object, even providing functions conditionally. Are you familiar with this ternary operator here? Essentially, this is the same as the mappable object. But if something is an array, we're going to sort it. If something isn't an array, we're just going to return it. So when we basically console log mappable stuff.map and get the value here, apples and numbers have been sorted. Lone string, I'm so lonely, has not changed. So how is this useful? A lot of times in programming, what you're really going to be asked to do is take a problem that has been explained to you by the business people in plain English and turn it into code. And it helps if the English language problem looks a lot like your code. So let's say you have this problem. What is 8 squared times 2 plus 2 to the 0.5th power, in other words, square root, minus 3 times 2? You will never be asked this except if your boss is that guy who loaded 40 watermelons into his station wagon in the math problem. Okay, so that's our question. I'm just going to leave that up on the screen there. This is how you'd kind of solve it the way you've been solving it. Essentially what you do is you create the number 8, have all these different functions which help, and you start from the number, you square it, you double it, you add 2, you take the square root, you subtract 3, you square it, you double it, and then you add 2, and you get 143.17 and change. Okay? That's absolutely fine. In fact, that's how most programs will do it. Here's the problem, though. It's kind of awkward. It's kind of backwards. The first thing you're not doing add 2 first. You're doing square first. So why is that all the way over there? Plus, here's the thing. That's an awful lot of parentheses at the end. What are we, writing Lisp? No. Here's another idea. remember, this is our identity item here, and this is all the helper functions we need to get there. That hasn't changed. We just are adding this identity concept. Answer 2 is identity number, and then we map that over square, because it's 8 squared, times 2, that's double, add 2 to the 0.5th power, square root it, subtract 3, square it, double it, get the value. It's the same value, because it's the same math. But here, it's easy to see what you're doing mapped to the way you would think about it in plain English. The steps that you're taking are, in fact, the steps you would take if you were solving it on a piece of paper. And that can make it easy to reason about if the people you're working with are familiar with this pattern. Now here's the thing. There's a trade-off. Just because now I've explained it to you, this looks easier, doesn't mean that if you see this in a code, you would have known what to do with it. I'm pretty sure that if I had just given that to you out of the blue, you would have no idea what the hell I was talking about. And you have no idea what the value is going to be. So that's what I mean when I said earlier that this is not necessarily good code. This is interesting code. This is code that might help you out of a jam. This is code that helps you think about code. But this kind of pattern is called a monad. And identity is kind of the simplest and most specific case. You can expand it a little bit to get this. And that's just. And that's another type of classic monad, which has basically the same map here, which maps to itself, applied the function on the value. But you also have the chain, which just returns the function on the value. And then you have this apply monad, where you can basically switch out which monad you're using by just applying a different monad. I've also added this inspect feature here so that, because it's sometimes hard to tell what the value is at any point. I want to be able to just return the just value that we just got. So basically return itself. But I also want to be able to understand what the value is. And I also maybe want to pass in a comment to help me get that. So we could add a value method here, or we can actually chain in this small I identity function, which basically is just x returns x, to get foo. So you don't have to even have a value that you can access externally anymore. You just pass in the identity function. Now remember, a monad is just a monoid in the category of endofunctors. I don't know what that means either. So a monad, for practical purposes, is just a specialized data structure. It's just like a linked list. It's just like a stack. Maybe a little bit harder to think about. It's a bit more brain melty, but at the end, that's all it is. So if anybody asks you what a monad is, don't answer a monad is a monoid in the category of endofunctors unless you want to be a jerk. Just answer it's a data structure that often returns itself so that you can have chainable methods. That's what it really is used for in the real world. Now, a lot of this stuff on monads, I didn't come up with it. I'm going to give credit where credit is due. Kyle Simpson, he's actually part of the HackReactor program. I believe he designed the curriculum. But he is definitely one of the smartest guys in JavaScript right now. I don't think he wrote this chapter when I attended, but he's written a chapter of Uno.js called functionallight.js. You don't have to start writing that down. I'll just give you a copy of the slide. But it's on GitHub. You can read it. He goes into identity. He goes into just. He goes into maybe. All sorts of cool stuff that, if you wanted to use it, great. If you decide not to use it, probably even better, because you want your stuff to be able to be read. The worst mistake I think you can make when applying for your first job is to write code that's so clever the person evaluating your code doesn't understand it. So again, remember, we write for humans too. This is that same function again, only this time we have inspections. So we can expect value 8 initial, after the square is 64, 128, 130, 11.4, 8.4, 70.5, 141 and change. And then when we get the identity, we can just return it. So that's mostly it for what I'd call the black magic, the stuff that might not be your best choice, but it's interesting to think about. So we're going to move on to the next part, which is the more practical stuff that I have learned here. This is things I wish HackReactor had taught me part 2, which is a follow-up to my earlier talk. If you haven't seen it, don't worry. This is like Transformers 2. You don't need to know the plot of the first one to get the second one. All right, so last time I spoke here was about a year ago, and I was working as a junior engineer. Now I'm a senior engineer, and I had posited in that talk that the difference between a junior engineer and a senior engineer was primarily one thing, and that is the relationship of how much mentoring you need versus how much mentoring you can do. And that still holds true. But now that I'm actually a senior engineer, there are a couple of other things that I've noticed. I'm just going to go over them now. This is actually from a letter written by a former Google employee, a recently former Google employee, who was actually free to speak their mind because they had just left the job on good terms. Google there was this email passed around Google. It was very misogynistic. I don't know, you may have heard of it, but this was kind of part of a reply to it. But the part that I want to take out was this part, which works in any context. And that is, essentially, engineering is all about cooperation, collaboration, and empathy for both your colleagues and your customers. If someone told you that engineering was a field where you could get away with not dealing with people or feelings, then I'm very sorry to tell you that you've been lied to. Solitary work is something that happens at only the most junior levels, and even then it's only possible because someone senior to you, most likely your manager, has been putting in long hours to build up the social structures in your group that lets you focus on code. And he's a former engineer at Google. I'm going to assume he knows what he's talking about. So as a junior engineer, I found that I was often told what to do in order to achieve the goals I needed. I certainly had autonomy. I could choose how to go about that, but I was told what to do and what was best for the company. And my job was to find a workable solution in a reasonable amount of time. This was what I called working tactically. And I often learned to recognize and avoid when I was over-engineering stuff. If you're just doing a for loop, you're not going to use the identity functor. You're going to use a for loop. Now, the difference as a senior engineer is that often I'm telling my manager what the team needs to do in order to achieve the business goals. That is, I'm now trusted with being told, we want to do this. How would you go about doing this? And what types of technologies, what types of approaches would you take? Do you think that we should use this legacy system, or is it time to pay off that technical debt? I'm trusted a lot more because I have a little bit more experience and a lot more knowledge about the different options that are out there to be trusted with that kind of opinion making. In short, I'm finding many solutions to the problem, but I'm choosing the best one, the one that best fits the needs of the company and the criteria before me. Basically, a junior engineer might be told, hook this up to a database. The senior engineer might say, okay, I know you want to hook this up for a database. What is our use case scenario? How many people are going to be connected at the same time? Is our data more relational or is it more document oriented? And that will help determine what database to consider. What is our front end going to be like? What is our back end going to be like? What library should we use? Should we use Bookshelf, Connects.js? Should we, in fact, even have a database? Should we just keep it all in memory? Those are the types of questions senior engineers deal with. So in short, I'm working strategically. And a lot of times, I have to go against my instinct that I had to teach myself to work tactically, avoid over-engineering, wasting time on something that we're never going to use. And I have to look at the future and what we're likely to need in the future and code to where over-engineering is a time saver, but only when it's a time saver. And part of that is recognizing when it's a waste of time and when it's not. Junior engineer typically uses the best practices which HackReactor is teaching you to get the best out of their own development and the best code out of their own typing. Best practices help you work within the team. And you focus learning on depth. When you get out of here, you're going to be tempted to learn all sorts of things. Unless it's directly related to your job, I think if you decide to study, you should study JavaScript in more depth. Because it's a lot better to learn one thing to mastery than to learn a whole bunch of different things. A senior engineer mostly uses the best practices not just to get the most out of their code, but to get the most out of their team. The reason I use unit tests, the reason why I use modular code, why I try to write in a way that code can be reused and easy to reason about is because I want to get the best out of the people I work with. And that doesn't mean a team I lead. That also means a team that I work with, other senior engineers. It also means that at this stage of my development, I've started focusing on breadth. That is, studying concepts not necessarily immediately related to my work, but concepts that can be applied to many features of my work, like functional programming, algorithm optimization. I really didn't understand JavaScript classes and React. And I used React for my thesis until after I graduated Makersquare, when I took some Java. And it's like, oh, now I get it. The code I wrote was crap. Don't worry. Everybody feels that way. Programming is a great career if you've ever wanted to go back in time and fight a younger version of yourself. Okay. I also understand the value of algorithm optimization. Like, right now I'm working on a side project that I'm trying to reduce from a big O(n) to the fourth problem to at least an O(n) to the second problem. And if I can, get it down even further. And I have to basically just rack my brain around that. Now there's a lot of tools that can help me, a lot of stuff in Postgres, which is why I chose Postgres as the database rather than Mongo or MySQL that helps with that. But you know, now we're going into things that aren't necessarily related to JavaScript code. So when it comes to making those decisions, one thing that I wasn't prepared for when I got out of HackReactor and into the real world was how many people used mobile devices. And we are living in a mobile world. I know that it sucks coding responsive CSS code. I know that it sucks coding for the worst possible device. I own an $80 smartphone. I wish I owned a $700 one, but I don't. And so I know that my site has to work on that $80 smartphone. Because most users, that's over 50% of web applications, are doing so from a mobile device. And if you have, this is the reason why. Let's say you have limited money and you're not a programmer and you don't need a fancy new MacBook with Iron Man on the front or a Linux computer or whatever. You just need a way to answer your email if a job thing comes in. Why are you going to spend $1,000 for a computer and then another $70 a month for a data connection when you already pay $70 a month and you got a free phone that does everything the computer does, at least that you want to do? And so another thing is that we're living in a global world. And a lot of places in the world don't use the Latin alphabet. Europe mostly does. Germany has a few extra characters, like that funky B, that's a double S. Italian, I think, uses accents, and French definitely has that funky C that has a tail. I'm not exactly what you'd call the most worldly of people, but there's also Cyrillic. There's also Hebrew and Farsi and Arabic, and all three of those read right to left, not left to right. And there's also languages that don't really use what you consider an alphabet, like traditional Chinese or kanji. And that's one of the reasons why mobile phones are so big, is because you can use whatever keyboard you want. You're not tied to a specific keyboard. Additionally, that's another big reason why emoji has taken off. So that's great. We have a more connected world, but it does present us with difficulties. Our goal is interactivity on a 3G connection in 5 seconds or less. That's the goal that I tie to, because if you're waiting more than that, you're going to browse off or you're going to get pissed off. So consider sometimes reinventing the wheel. As you go through MakerSquare, you're going to be exposed to all these different great libraries. Use them. They're great. They're designed for a purpose. But every time you add a library, unless that library is really light, you're going to add to the size of your bundle. You're going to add to the amount of time that it takes. So if you only need maybe 1 or 2 functions, consider rewriting them yourself. It's one of the reasons why I think it was so, I didn't appreciate it at the time, but rewriting underbar, you're going to be using functions like that, even though you could have just imported underbar or Lodash or whatever. You could have just done that, but then you have the entirety of underbar. Now, there's ways to do tree shaking and things like that to get it down, but if all you need is one function, just write it yourself. It's not that hard. You don't have to really think about it. Just reinvent the wheel and save you a little bit of load. Here's some of the libraries that you're going to be working with and their sizes. Now remember, we want 5 seconds to interactivity. And 3G can be as slow as 250 kilobytes per second. Ember, that framework's about 435 kilobytes. So already we're using up 1.5 seconds. Angular 2 with RX, 766 kilobytes. Even React DOM, that's relatively lightweight, but that's still about half a second. Vue is pretty quick, but we can still get down further. Now, I do recommend that you use React or Angular for your thesis project, because those are the projects that, like when people search for keywords, they're searching for React, they're searching for Angular. Use them. Don't worry about bundle size in your thesis project. You're looking to write something that's good, that's clean, that does something in a way that's coherent, that's bug-free, that looks good. It's your showcase piece. Don't worry about bundle size, and use the technologies that you think are going to be out there in the market that people are going to want. But consider these. Preact works almost exactly like React, and it's 16 kilobytes. Mithril, which is really small, uses a virtual DOM, but I don't think it has support for JSX unless you import it. But that can get down to 8 kilobytes. Moon is 6 kilobytes. There's even something called HyperApp. I haven't tried it myself, but apparently it's a framework in 1 kilobyte. I don't think it's got a whole lot of bells and whistles. I wouldn't count on it to keep track of your entire life cycle events, but it might be worth looking at if you have a really small project and you really want to keep it light. Here's some sizes that are minified but not gazipped for libraries that you might use that aren't frameworks. Like the Material UI library. I use that a lot because it looks cool, and my bosses are like, we got to have this bell and whistle and stuff like that. But that can be up to 3 megabytes. Nobody has time for that to download. I'm on Google Fiber, and I'm a little bit worried about that. So I actually use it, but I employ a number of things to basically pare it down, get it as small as possible. React Bootstrap uses Bootstrap with React. That's another 450 kilobyte. Lodash, what I mentioned before, if you're importing Lodash, that's 150 kilobytes. So sometimes it does pay to reinvent the wheel, especially if you only need a part of the wheel. Next section is typed JavaScript, which was kind of sort of a thing, but now it's kind of getting a little bit more traction. And I want to talk a little bit more about TypeScript and Flow and when you would want to use them versus the vanilla duck typing JavaScript that you've been using. So TypeScript does make code easier to read. That is TypeScript and Flow, because they're both, we're talking about whatever type systems you want. When you pass in a parameter, that parameter could literally be anything. It could be a function, it could be an object, it could be an array, it could be an array of functions, it could be literally anything. In C, if you have an integer, you know it's an integer. It's always going to behave like an integer. All the methods that are on an integer will be on an integer. You know what's going to happen. and it does make code a little bit easier to read and reason about. So it also eliminates a lot of the need for documentation. Like, if your code says it's an integer, you don't need to put in the comments, hey, this is an integer. It also eliminates a lot of need for unit testing of the type, make sure that this parameter is an integer. So it does eliminate a little bit of that. When you refactor, it's a little bit more reliable because you can catch errors at compile time, basically saying, oh, you passed in a float to an integer. Well, JavaScript doesn't really have floats. You passed in like a string to an integer or a function to a string or something like that. Sorry, just a little bit. I've been kind of moving around a lot. So refactoring, making it more reliable. Better IDE support if you're using Visual Studio Code. It has TypeScript and Flow support built in. It allows you to eliminate those unit tests. But, and this is a huge but, and this is why I don't use it, it's not standard JavaScript, which means that you have to set up tooling in order to use it. And you can't just go ahead and assume that every person has that tooling. And complex data types, that is objects, arrays, functions, especially if they also have methods or properties, like a function that has a property or a method. That can be hard to write the correct type for. Promises, especially, are really hard to write for. Writing typed code also takes more time, and it's a big productivity hit. So you may end up spending more time than you need to write the code. So when you should consider using a typed JavaScript is when your code is part of a larger application operated on by a large team or a large number of teams. It helps standardize things. It helps you to reuse code knowing immediately what each function takes and what doesn't, so that you can basically create kind of a cross-code environment without really complicating things, without having to create a new, essentially a new way of basically, it just helps you organize things better across a large number of developers. Additionally, if your code is crucial to the success of the company and can't ever have a type error at runtime, if it's going to be very long-lived and it's going to pass through a number of hands, that might be another time to use typed JavaScript. And if you're using Angular, you pretty much need to. It's one of the reasons I don't use Angular. But if I ever had a job that required me to use Angular, I'd use TypeScript. I'm not going to be a jerk and say, oh, I'm not going to work at this job. It uses a technology I don't like. No, that's a problem between keyboard and chair, not at the back end. So when you should avoid typed JavaScript is when your project is not expected to be developed over a long period of time. In other words, anything you write here at HackReactor is probably not going to be developed over a long period of time. And if it does become something that's developed over a long period of time, probably better to just refactor it from the ground up if you actually make a company out of your thesis project, for example. Your project's relatively simple. It's a single page app, connects to a single database. You don't really need the overhead for that. You can pretty much reason about the entire thing with one developer. You're under time pressure. Sometimes it would be useful to, over the long term, do it in a typed JavaScript, but you just don't have the time. You have to hit the deadline. Adding or including a typed system can introduce a significant time cost, so that might be one time you might want to avoid JavaScript, at least for right now, and maybe return to it later. So these are the two main types of typed JavaScript right now, TypeScript and Flow. If anybody asks you the difference, the main thing is that TypeScript is a superset of JavaScript that transpiles to JavaScript that was invented at Microsoft, but it's used at Google. It's practically a requirement for Angular 2+ and 4. It checks type during the transpilation step, and it throws errors, and it stops the transpilation if the type doesn't match. Flow was invented by Facebook, and essentially stripping out all the flow notation, which is done automatically with by Webpack and other things, will return valid JavaScript. And that JavaScript doesn't necessarily need transpilation. And additionally, instead of checking and stopping at transpilation, it can check the types at any time. Which means also that if you strip out the types, even if the types don't pass, you're still going to get valid JavaScript if you transpile it after stripping out the types. So even if your typing is wrong and your code is right, you can still use the code. So incorrect typing won't throw a warning, but it will prevent transpiling. Sorry, incorrect typing will throw a warning, but it won't prevent the transpiling. So anyway, that's Flow and TypeScript. And now that I've gone through a whole bunch of different technologies and black magic and craziness in the job workplace, this is the part in the lecture where I take your questions AMA. Howdy.
Hi. So you have a side project you're working on.
Yeah.
And it sounds like you might be doing that you might be experimenting with a functional language. Am I right in thinking that?
No. I'm experimenting with a functional language, but not for my side project. In fact, experimenting with functional languages is a side of my side project. I have many sides. I'm like an onion. I have layers. No, wait, that's an ogre. There are certainly functional programming concepts that I got by looking at Elm and Haskell and Elixir that I didn't really get too deep into the language, but it helped me understand why those design decisions were made. And I can understand certain scenarios where it would make a lot of sense for me to use, say, Elixir's web server rather than Express, even though I know Express's syntax and I know how it works a lot better than Elixir's, because Elixir's better at handling things like concurrency. So if it's a really large app, you might want to consider using a language that doesn't have mutations built in. That is, everything is a const. Well, not everything is const, everything is immutable. So it's even better than const. There's also the fact that studying other languages, the great thing about JavaScript is that any kind of concept from another language that you like, you can pretty much use in JavaScript. If you really like classes from Java, you can use that in JavaScript. We now even in ES6 support the class keyword, so you can use it almost exactly like Java. If you like the functional programming, you can create a monad that comes built into, say, Elm or Haskell, and just create that and use it like you would in those other languages. So there is a lot of experimentation. Just because it's not in your language, when you get to a certain level, doesn't mean that it's not an interesting idea. So read what you can, read a broad variety, but for right now, focus on JavaScript, because that's what's going to make you a deeper developer. And you really do have to understand the code in kind of like your base language before you learn it in a second language. It would be kind of like if I tried to learn Italian before I understood what verbs were in English. And someone in Italian explained to me the concept of verbs, and it's like, I have no, I know basis, reference, think. See, because I don't know verbs in English, so I'd have to talk like a caveman. Which is how I got thrown out of Latin when I was in high school. So that is kind of a side of the side. Don't worry too much about that.
You mentioned that when you gave the talk last year, you were a junior. So I'm just curious how, in such a short amount of time, you were able to learn or get good at this and become senior engineer.
It helps that I have no social life. But it also helps that I'm just naturally curious, and I always will be. And I also know when to relax and to take time off, when to let ideas settle in, and to always just keep experimenting and trying out new things. Now, it is true that I became a senior engineer in a short time. Part of that was that I took a job at a smaller company in order to basically get to a senior engineering role faster. It was a career decision. I'm still doing everything a senior engineer does, but they were willing to take a chance on, forgive the pun, a more junior senior engineer than normal. That said, while it's only been like 2 years since I graduated from Makersquare, I did a lot of programming, although I didn't know it was programming, before I came to HackReactor, and I accomplished a lot of stuff. Like before I came to HackReactor, I actually kind of created an $11 million super PAC and all the software that ran with it. That's kind of like my claim to fame. It's the thing I put up on my resume. It was pretty much an accident, but I worked with a guy called Larry Lessig, and he said, I need something in 15 days that will have all the functionality of Kickstarter plus be compliant with the Federal Election Commission for a 401c. And I said, I can't do that. Well, you're the only person left. So I did it, and it kind of sort of worked well enough to where we could bring more people onto the team and get more people. So that's where we are now. Was that it was after that when I had that experience. So when it comes to programming, even before that, I was still doing HTML, CSS, and I'm kind of a whiz at CSS because I've just spent so long with it since the 1990s. Because I was a content marketer, and content marketers need to know HTML and CSS. The rest was just programming. And yes, it takes time. And there are some concepts that even I have trouble wrapping my head around. I am not necessarily going to make the best decisions, but at least I know the process for making that. I'm very well aware that, as I said, I'm kind of a junior-ish senior engineer, but I do know what role a senior engineer plays, and I'm doing that role to the best of my ability, and I'm growing and I'm learning as fast as I can. It's just that I put a lot of effort into it, and really, that's what it comes out. It's a function where when you put more into the parameters, you get more in the return. And that's not just good old-fashioned Leave It to Beaver sitcom thinking. That's the real life thing that there. So, all right.
As a senior engineer, how much of your time are you spending actually coding versus leading your team?
I don't actually lead my team. I'm part of a team of senior engineers that works with other more junior engineers, mostly outsourced. So, yeah, I know people have to go. So, essentially, I spend about half my day coding, about 1 hour to 2 hours in meetings to make sure we're all coordinated. And probably the rest of my time, I'm looking over other people's code, or I'm researching other decisions. Lately, I've been working with one team called Let's Grow, which is actually some contractors in the Ukraine. We have to go with contractors because we're a smaller company. We only have an in-house dev team of about 7 people. So, and most of those are senior engineers. Not all of them, but most of them. Come on in. And so I think that's somebody's ride. So, all right. So anyway, how much time do I spend leading my team? Well, as much time as they need, really. A lot of time I can basically just look at the code, basically say you're on the right track, you're doing a great job, see ya, and just leave them to that. If there's something that needs like more explanation, I'll schedule like a meeting with the rest of the team and I'll say, okay, this actually needs to be organized in this manner. Sometimes I have to explain to the outsourced junior team why they can't do things a certain way. Usually it's because the data on the back end isn't ready yet because I'm waiting for another team. It's a real world scenario. Not ideal, but it's real world. Honestly, I never really thought about it in that way, but I do spend about 6 hours a day on my own code. And when I say my own code, a lot of that is code where the first draft has been written by the junior developers, and now I'm being asked with, can you organize this feature or refactor this class or something? Can you fix this bug? Here's the thing about being a senior engineer. You're still going to be doing the job of an engineer, and you're just expected to do it better and faster, and to be able to mentor other people as you go along, and to criticize and make good collaborative suggestions, and to get the best out of the people you work with. Honestly, it's a nebulous line, and I wouldn't say that I'd be a senior engineer at another company necessarily. If I was at Google, they wouldn't even consider me a junior engineer because their junior engineers have PhDs and apparently have their brain implants overclock like in cyberpunk novels and all that. And I've tried, but I can't keep up with those guys. They're crazy good. Any other questions?
Yeah, what's the number one mistake or pain point you see coming from the more junior members and engineers of your team?
The pain point that I see, see, the problem with that kind of question is that I'm kind of like calling people out on something that they did poorly when they didn't really do it poorly. The biggest pain point, I think, is that a lot of times they will do something in a clever way and then not explain to anybody else how they did it. This is actually something that I struggle a lot with the legacy code of something called the application portal, which is what I'm working on right now. And that is, it's React with Redux. But a lot of the features that they've used are through these third-party libraries that are kind of black boxes that I've never heard of. And eventually, working with the code, I was able to figure out what each library does, how the Redux store was organized, but it would not have been how I would have organized the Redux store myself. It wasn't intuitive, in other words. If something's intuitive, then you can forgive not having like perfect documentation or anything like that. But if something is esoteric, if something needs explanation, be sure to explain it. And if you go with a certain thing other than another thing, make sure you understand why you're using that. Even if that explanation is, I don't know any other way to do this except to use this. Here's the GitHub page which documents it. You can put that in the code. It'll get stripped out when you do the transpile step, but it helps the code become readable. You can absolutely put Stack Overflow stuff into your code. In fact, you can even put that into your thesis code. That's not cheating. It means you know how to get information and how to apply it. So in that case, that would be my particular pain point. It's different for everybody else. Every junior engineer and every senior engineer makes different mistakes. The trick is you try not to make the same mistake twice. And if you do make the same mistake twice, you try not to make it a third time. And if you do make it a third time, you document it and make it a feature. Now that I'm thinking about it, as I said, it wasn't necessarily that the code was in any way bad. It was actually far cleverer and in a way better than I would have come up with. My so-called junior team had a better way of doing things than I did, but because they did it in a way that was cleverer but harder to understand, it wasn't as useful as a dumb way that I could reason about. So, long story short, comments are important. Making sure that your functions do one thing and one thing only, and to reuse what you can when you can, to make sure your files are organized in a simple way. Even little things, like one thing that stuck in my craw was that, boy, that's an old phrase, stuck in my craw. One thing that stuck in my craw was that I'm using Visual Code Studio or Visual Studio Code or whatever. And at the top, it'll basically say the name of the file name that you're working on because you have all these tabs open. And for a very clever reason, the way that the file structure was organized was that he would have a base index.jsx file in all these different folders that then referenced a local component. So that way, if a component was only local to that container, in other words, if that index.jsx only needed the files in that container, you could actually put that in the folder as like a subfolder of components, and then index.jsx kind of just drew from that, and you could reference it in the code simply by leaving off index.jsx. The code would know what file you're looking for, which is great. It's a really good way to organize things, separate your concerns. What's not great is that every time you open up one of these files in Visual Studio Code or Sublime Text or Atom, it's going to say at the top index.jsx, and you're not going to know what the hell file you're working on. And And so that can be really problematic when you have a whole bunch of different files that are structured fundamentally in similar ways, but do very different things. There has been many a time when I don't understand why the code isn't changing, only to find out I've been working in a completely different file and saving something completely different. So yeah, you want to avoid that if you can. Give, that was just, a mistake, and it was a clever mistake. I see why they did it. It wasn't necessarily wrong to do it. It wasn't in that sense. It wasn't bad code, but it was bad for the workflow. It was bad for the company, and I don't blame them at all. I basically said, you know what, this is clever. It's not how I would do it, but it's not that big a deal. We're just going to continue on with that code. If I were to refactor it, maybe I'd do it differently, but there you go. So yeah, that I think is like the biggest rookie mistake, is not writing in a way that is easy to understand, that's easy to use. And also a rookie senior mistake is not making it clear when a mistake has been made, because otherwise they're going to keep doing that same thing. One of the reasons why I continued with the index.jsx was because I thought it was clever when I first saw it, without realizing what kind of confusion it would cause down the road. So later on, the team kept using that convention, thinking that it was just a temporary thing that they would eventually grow out of as the code matured. But no, they used it over 100 different files. You know what? Now I got to live with that mistake. That's my mistake. I actually have a boss named John, and we were just talking at one of those after work events, and I was explaining this to them, and it's like, really, don't you think you should have made Vlad, who's the junior engineer, don't you think you as the senior engineer should have made him code your way? And I said, absolutely not, because on this project, Vlad's writing 90% of the base code. I might write the final 10%, and the final 10% might take the final 90% of time. But in this case, the person who's writing the most code, who is working with it the biggest, should choose the conventions, and then anybody else who's doing cleanup work should conform to those conventions. If anything, it was my fault for not setting up the conventions clearly in a document, and that was my mistake. And I will take full blame for that, because I'm still learning myself. And when I say I'm a junior senior engineer, I mean exactly that. I mean that in 10 years, I'm going to be a senior engineer. But it's going to take time. It's going to take experience. Just try to learn what you can from your own mistakes, and especially the one thing that will shorten the time that it will take for you to graduate from a student to a junior engineer, and from a junior engineer to a senior engineer. It's not just to learn from your own mistakes, but to learn from the mistakes of others. That means reading. That means study. That means practice. And it means trying out new things even when you're not comfortable. You know all this. I think this is important because I know someone who's coming into this program now who is just very, very uncomfortable with everything. It's like, I don't know if I'm good enough. I don't know if this is the right move. I can tell you that you're here. You guys are part of a very rare breed. You guys took a significant risk in coming here. There's no doubt about it. Paying the money to come here is not a guarantee, but it seems like a good idea. And when you evaluated the risk versus the potential reward versus the possibility of success and the possibility of failure, you decided to take the risk. A lot of people are risk averse. I'm risk averse. It's human nature to be risk averse. But when it came to something that you decided that you wanted to become a better coder, or a coder in some cases, that you wanted to be able to have an intellectually stimulating, not just job, but way of life. I mean, I'm sure all of you are already dreaming about code in your sleep. That's going to stay with you, because you're an engineer now. Well, you're not an engineer yet. When you graduate, you'll be an engineer. There'll even be like a little ceremony. You'll have mimosas maybe, and say, I am a senior engineer. I'm an engineer. But what you're learning to be is what you want to be. And so few people, I think, have the bravery and the guts to follow their dreams and see it through. So, I mean, you guys, and this goes for anybody out there watching this, learning programming, even if you don't go to HackReactor, if you are taking the courage, or if you have the courage to take what you find compelling and to learn what you can about it, to really go for, this sounds corny, but your dreams, and you take reasonable steps towards achieving them, then that's just very powerful, because so few people actually go with that step. They basically just accept what they've been given. And I'm no exception to that. I accepted what I was given for about 20 years. HackReactor wasn't my first attempt to learn to program. I attempted to learn to program in 1997 when I graduated high school. I majored in a computer science program at a university. And, sorry, I'm getting a little choked up. I shouldn't be, but I am. When I was at that university, I don't know what it was. Maybe I just wasn't mature enough. Maybe I just had a lousy teacher. Maybe I just didn't have the tools. Remember, in 1997, there wasn't really a Google. So I had to learn from textbooks the way that the university taught computer science. And back then, computer science was an offshoot of the math department. And so I kept getting told that because I couldn't pass Calculus 2, that I'd have no future as a programmer. And I changed my major to history. And while I was always interested in code, and I always experimented with HTML, CSS when that came out, and I was always interested in like modding and different things, and I tried out different little things in the console, I never considered myself a programmer until I got dragooned into that $11 million super PAC thing. And I was literally the bottom of the barrel that they scraped. I always believed for about 20 years of my life that I wasn't good enough to be an engineer. And I can tell you that, like the moral of the movie Ratatouille, the moral is not that anybody can cook, but that the talent for cooking can come from anywhere, and anyone with the passion can develop the talent. And that's what I learned here at HackReactor. And so I'm an engineer now, and I don't really regret the 20 years I spent. They weren't exactly wasted. I also helped get an innocent woman out of jail through marketing. Well, through journalism, marketing, content marketing. It's all weird. But she got a new trial, didn't have to go to jail. I'm happy with that outcome. And that wouldn't have happened if I became a programmer in 1997. But for the longest time, I felt like this was something that other people could do that I could not. And I'm very glad that that bottom of the barrel had to be scraped, because otherwise I never would have known what I was capable of, and I never would have discovered such a wonderful, not just a career, but a community of wonderful people dedicated to the sharing of ideas. And yeah, and so I'm gonna dab the tears from my eyes now, and maybe I think I'm going to edit that out of the video. It's a little bit too schmaltzy for me, you know. I know it's getting late, but I do really want to answer everybody's questions. Anybody else have questions? Yeah.
Okay, how do you know, how can you tell that you are now a senior engineer?
I have to report it to the IRS. It's on my, they ask me my occupation, I have to say I'm an engineer. Really, a senior engineer is a construct. If your boss says you're a senior engineer, if the CEO says you are a senior engineer, if you can put on LinkedIn, I am a senior engineer, and nobody corrects you, you're a senior engineer. Specifically, in my case, I was hired as just an engineer. Junior or senior didn't enter into it. And what happened was that later on when I started working there, my boss was like, Brian, you're a better engineer than the one we thought we were hiring when we hired you. And that was a hell of a compliment. And then later on, I got introduced like a company meeting as the new senior engineer in front end. I don't know if it was a formal meeting or an informal meeting. It doesn't matter. I'm counting it. I showed this slide deck where I clearly identified myself as a senior engineer to my boss at Deveris, and he said, "Yep, you're a senior engineer." And really, as I said, even if I wasn't a senior engineer in title, I know what a senior engineer has to do. I know the kind of decisions a senior engineer is trusted to make that a junior engineer is not. And for the most part, so far I haven't let the team down when it comes to any of that stuff. Knock on wood, or Formica in this case. Yeah, so I knew I was a senior engineer when other people started calling me a senior engineer. It's also kind of like enlightenment in the Zen sense, in that if you think you got it, you ain't got it. If you think you're enlightened, you ain't enlightened. And if you think you're a senior engineer, maybe you need to reevaluate that and maybe get some buy-in. You know, how would you characterize me? And don't ask your boss, ask your friends. How would you characterize what I do? And so yeah, that's part of it. Another thing, as I said, is that I'm probably one of the more junior senior engineers that you'll meet, in that I haven't had a whole lot of experience being a senior engineer, but that is what I am. So as I get more experience, it's going to be apparent to more people that this guy knows what he's talking about. You know, it's not like you flip a switch and suddenly you're a junior or senior engineer. It's not like you flip a switch and you're a teenager versus you're an adult. Unless you're talking about the law, in which case up to 17 and a half, you are tried as a juvenile, and then you can be tried as an adult in those 6 months. But yeah, it really is, it's not about the destination, it's about the journey. And I'm still on that journey. And assuming that the next cheeseburger doesn't give me a heart attack, I'll be on that journey for quite a long time yet. So let's get the one without the bacon this time. So yeah, anything else? One last thing, and I guess this won't be part of the video. Remember when I said that promises were a type of monad? Remember how a promise will always return a promise object? That's the same pattern, and that's one of the reasons why it was so mind-blowing to me when I saw monads, and I compared them to promises. Because I had been working with promises for a great long while without realizing that they fit this larger pattern. And I had been working with references for a good long while until I realized about pointers. I realized that references fit this larger pattern. And the great thing about taking a small pattern and realizing that it fits part of a larger pattern is that you can now take concepts from that smaller pattern and apply it to different areas. If I wanted to, I could write my own promise library that also could be mapped over. I could write my own, I don't have to because someone else has already done that, and I probably won't because it's a waste of time because someone else has already done that, but I could because I understand now how these ideas are organized, how these difficult concepts are created. And it's happening to you too, even if you don't realize it. You're taking these little concepts like functions, and then you're applying them to higher order functions. And then you're applying higher order functions to methods. And all in all, you'll be able to essentially move fluidly from the trees to the forest. And the forest is infinite. It is the whole sum of human knowledge, of which we are in a subforest called computer engineering, and we will be part of that. And it's a wonderful forest, and there's always something new to explore. Not only does it keep growing infinitely, but there is a vast and rich history to it. And I'm glad you guys are in the forest with me. I mean, I haven't known you for long, probably about 3 hours now, but already I can see that you guys are asking the right questions, that you're reasoning about things in the right way, and just going to be hell great engineers. Did I say hella great engineers? I hate saying hella. You're going to be hella great engineers when you get out of here. And I think what you do will surprise past you, because if I had known what I was going to be doing, even when I graduated, I would have been surprised. I would have said, there's no way I'm working on a project which takes this complicated, convoluted algorithm and turns it into a product. I would have never realized, hey, I'm going to be given a function that's going to be 50% on monads. I didn't even know what a monad was. I thought it was the singular version of moners. So in addition to having no self-confidence, I also didn't know my Latin roots. But yeah, it's an honor to join this community of engineers, and I think you guys are going to do us proud, unless one of you is the person who writes the nuke Las Vegas function. In which case, remember, write a nuke city function and pass Las Vegas in as a parameter. Thanks, guys. Thank you for listening. I think that's it. I probably held you back like way too long. Oh God, it's what, 21:37? What time is it? 9:37. Okay, good. I thought we had gone into a crazy land, or at least onto a military base. Yeah, I don't want to keep you guys too much longer. You guys, I'm going to be around here for a couple more minutes while I pack up. Feel free to, if you want to ask me questions one-on-one, anything like that you were embarrassed to share in front of the class, think of me as I don't know, a good metaphor, and I can only think of a bad one, like the health coach that says, if you have any personal questions, you can talk to me after class, like in elementary school as you went through puberty. I don't know, because I never went through puberty. I'm still kind of waiting for my voice to deepen and for the zits to clear up. Great to be talking to you, and I'll hopefully see you guys out in the workforce soon and at some meetups. And if you guys ever want to look for a job, why not the Veris, which is actually probably going to be bringing on some people right around the time that you graduate, if we're lucky, and our 9:30, which is the September 30th deadline, is met, and it is a hit, and a whole lot of other things. But yeah, and remember, you can always email me. You'll have my email address in the slide. I'm sorry I don't have a Twitter or a website. I'm kind of in the middle of websites right now. I'm basically, I tried to have my own domain, and then I realized I'm just going to go back to Medium. So in the meantime, I'll, So thank you guys for sitting through my lecture. I appreciate it.